Okay guys, so video 5 starts us talking with common logarithms. Remember, the logarithm with a base 10 is called a common logarithm, and it's denoted by omitting the base. So if you see that log of x, you know that that's the same thing as if they'd written log base 10 of x. And so we know then that log base 10 of x can equal y if and only if 10 to the y equals x. Same rule we did before, just has a base of 10. So there's no reason to have to remember that last part, except for you know that log base b of x equals y and b to the y equals x. And I actually forgot to put the x right here. So what I should have had actually written there, I'm sorry, is log of x equals y, because even though it's not written, let's mark that out, even though it's not written, we know it has a little base of 10, because anytime the base isn't written, it's going to be a base 10. Alright, very similar to it is our natural logarithms. So natural logs are just as a logarithm with a base e, and it's denoted by the natural log of x. So if it's log base e of x, we actually write that as ln, meaning the natural log of x. And so anytime you see ln of x, you know that really there's a little base e there. And so the same idea we had, if you have the natural log of x is equal to y, then that means that e to the y has to equal x, because how we know our little base is an e right there. Alright, so let's do some evaluating. So in example 8, it wants us to evaluate each expression. And a is going to be the natural log of e to the 4th. So we're going to do the same thing we did in the previous examples. It's in log form, and we're solving for it, so we're going to set it equal to y. And so to work this out algebraically, remember, your base is going to be the little number here at the bottom. Well, there's not a number written there, but we know it's a natural log, so it automatically has a base e. So there's your b. All of this here then is your y, and that is your x. I'm sorry, I said that totally backwards. I was going to the form. So it's log base b of x, and then this is your y. I was thinking of where we're going. So we know that our base is going to be e, our x is going to be e to the 4th, and the y is going to be y. So now let's go to exponential form. So our base b, which is e, to the y, which is y, equals x, which is e to the 4th, and then using that one-to-one property, we end up with y equals 4. B wants us to solve if we have the natural log of 1 over e to the 2.5. Well, again, it's in log form, so we're going to set it equal to y. Remember, you have a little base of e, even though it's not written there. So our base is e, our x is the 1 over e to the 2.5, and our y is going to be y. So when I set it up in exponential, I get b to the y equals x. Remember, we don't like fractions when we're doing this, so we're going to bring this up, and that's going to make that a negative exponent. So it makes that e to the negative 2.5, one-to-one property. We know then it's equal to negative 2.5. All right, and let's see, C wants us to take the natural log of 3. So I could set it up in exponential here. So I know that my base is e, my x is 3, and my y is y. And so when I set this up, I get b to the y equals x. But there's no way to get e and 3 to have the same base. So therefore, I can't actually solve this using exponentials, but I could go ahead and just put this in my calculator to get a decimal answer. And so let's do that. So in your calculator, because this didn't work, let's type in the natural log of 3. Now, natural log is going to be found on the left side of your calculator up above the on button if you're using the TI-84 83, something like that. So you're going to do the natural log of 3, and it equals, and it should tell you it's approximately 1.099.